See the word file, the lab manual which I've shared in your presentation. Is it visible to you all? Okay, shall we start off?
Yes, ma'am.
Let's just give 2 more minutes time for your friends to join in. Okay, so today's experiment will be the table experiment. I hope you have no doubts in the foundry part which we have done over the last few classes. Boys,
No doubt, ma'am.
no doubts. What are the tools we used? Can you name them? Let's see how much you have, remember.
Ma'am, runner, riser,
Runner, riser, very good. Then
and drag.
drag, drag. The one which is placed down is drag or cope?
Stop, ma'am.
Copa.
I got confused.
Drag, cope, then
Leveler,
leveler, lifter,
sand rammer,
sand rammer, sprue rod, round rammer, then vent rod. Boys,
yes, ma'am.
okay. So with these details we have done in the foundry, we have done finished 3 experiments here. One is with solid pattern. What is the pattern we used in the first class? What pattern you used? What solid pattern you used?
Hexagon, ma'am.
Hexagon. Hexagon with center
Square.
square. Okay, hexagon with square. Then next class we did with split pattern, right? The pattern was divided into 2 halves. In both the cope and the track, in both the half pieces were placed, and we ramped, and then we realized that how the mold could be joined, and once when the casting is poured into these molds, how patterns will be formed, right? We saw this component in the last class, right? Last before class. In the last class, we covered about the experiment without using a pattern, because in some of the industries when they're trying with a new component, that time to have these jigs and fixtures will be difficult, right? Every time we cannot invest on these kind of fixtures, right? So sometimes it's better to have new designs when they're coming, when they're in the trial stage, or when they're trying to experiment something new, they would try to have their own design, right? In such case we can also draw the pattern and make the shape in the sand mold, and then pour a casting and get the desired product what we want, right? In the last class also I think I showed you some videos on how IC engines casting were made and how dry castings were made, right? We have seen, I hope you all remember that, what how the how the working of the process is shown in the industries, right?
Yes, ma'am.
So, is there anybody who's having doubts in the foundry classes? If you have no doubts, I'll move on with the first table experiment. You have no doubts, boys?
No doubt, ma'am.
Okay. So today we are going to do the experiment on grain fineness test. Okay. So this experiment is to determine the average grain fineness test. See, if you are happen to visit the beach, or if you are happen to during the construction, if you take that sand which is laid there, if you open each sand granular is different in size. Have you observed that? Have you observed that? Have you observed that, boys?
Yes,
Have you
ma'am.
observed that? So does all of them have the same size?
No, ma'am. Some will be big and some will be small.
Huh?
Some will be big and some will be small, ma'am. Size differs.
Size differs. Some will be very minute, some will be a little larger. So each size varies from one another, right? So definitely have the we need to study about the grain size, and the grain size will not remain the same for all component, right? For all applications, we there is a variation in the grain size which is required by the organization or by the foundry department, right?
Yes, ma'am.
Yes, right. So, mm, so based on that, we are going to do the experiment on grain fineness test. Now, we have already seen the aim of the experiment. Let's look at the apparatus. In the apparatus, we need a digital balance. What do you mean by digital balance? What do you mean by the digital balance?
I'm weighing scale with the digital display.
Very good. A weighing balance which has a digital display. Here we have something called the sieve shaker equipment. I will show you this equipment. It's, you know what is a sieve? Do you know what is a sieve?
Yes, ma'am.
What is a sieve?
It is used to separate those big chunks from wheat.
Yes, you would have seen that at home, our parents must have used those sieve to basically remove the stones or some other foreign component material in our usual grains, right? So sometimes stones will be there to remove all that. They would have used these to remove stones, dust particles in the grains. The parents would have used that, right? So similarly, we have a sieve shaker equipment only. This sieve shaker equipment has a set of 10 sieves, right? These 10 sieves, depending upon the size, in a descending order or some in the ascending order, would have placed in the, usually it will be then the descending order only. In the descending order, it will be arranged in the equipment, and then you will have which is interconnected with a vibratory system. Once when the switch system is switched on, it vibrates for some period of time. Like manually at home, our parents or somebody would be shaking it, right? Now instead of manually shaking, this sieve equipment will go through a vibration process which is machine driven. So once when it has a shaking process, now the sand particles which is put inside this will settle down according to their sieve size, that has been ranged in different sieve plates. Am I clear?
Yes, ma'am.
Okay, and next we want a stopwatch. Stopwatch, you can use your watch or you can use the stopwatch, which is a most stopwatch is there in the lab. Otherwise, you can use your own watch. Is it clear? The material we use here is your silica sand. Okay, the material we use here is a silica sand, right? So the theory is the base sand, which is having different grain shapes, which can be round, angular, or subangular, will basically will have some additives or binders, right? So it's relatively have to be free from these additives and binders. So these sands need to be uh, should be of same size when we are trying to do some compression test or shear test with respect to the sand. So in order to make sure that the sand particles that we have chosen have to have the same size, it has to go through this kind of process. The size of the sand grain is basically designated by the grain fineness number. What is this number? This number indicates the average size of the grain size present in the given sample. Now the sieve plates will be there, right, in a set of 10 sieves. Now whichever sand settles down in whichever sieve plate number, that one will be the value of that grain size, right? That particular value of the grain size. The test of the fineness is conducted by screening the sand grains by means of a standard sieve that are graded and numbered in this sieve shaker equipment. Okay, so in a number of these embossed will basically, I'll show you when we are doing the experiment, when you are basically going to look at a video. In that we will show how this grains settle down in the different sieve plates and how we identify with respect to those particular plates of the sieve, right? So the procedure is, any doubts with the theory? Why do we have to do this experiment? Have you realized it? Like how you did your molding process. Similarly, when you're doing the sand mold, right? If you have sand particles, one and other with different sizes, is it okay with you all? Do you think the mold that you obtained will be fair enough? And what will happen to the binding capacity? The addition between one particle and the other particle, sometimes there might be some kind of gaps in between them, right? To overcome that, we are doing this experiment to make sure that the grains which we use are of same grain fineness number. Boys,
Yes, ma'am.
is it clear?
Yes, ma'am.
Akash, Ayush Chandra, are you
Yes, ma'am.
following?
Yes, ma'am.
Yatindra, Bhavna,
Yes, ma'am.
okay. Now we look at the procedure, right? The procedure is the sieve set is stacked. First, we have to make sure the sieve set on the sieve equipment. It has sieve set is stacked or arranged with the top sieve being coset. Basically, which means to say that the sizes of the sieve in the descending order it will be arranged, right? So it will be arranged from large value to the small value. It has to be arranged on the equipment, right? The sieves between the top and the bottom are placed in order of fineness. Then what? We are going to weigh a 50 grams of sand, dry sand. You remember that basically some students ask me, ma'am, why is that dry sand being put on the mold? Do you remember that sand when the sir sprayed it on your mold? You all remember?
Yes, ma'am, I do remember.
Yes, you all remember, right? That sand we are
Yes, ma'am.
going to weigh 50 grams using our digital balance and is placed on top sieve. The top sieve will be there now. And see if I have a picture of the sieve here. Okay, we don't have a picture of the sieve here, but I will show you. On the top of the sieve, we're going to weigh 50 grams of dry sand and place it on the top sieve. Okay, and close it and make sure cover the lid and is secured to the vibrator. Okay, it is going to be secured to the vibrator. Then what happens? Then what we're going to do is these sieves are vibrated for 15 minutes. there is a knob. You need to switch on the motor. After switching on the motor, how fast you want to do it, slow or fast, like how we have a mixie, right? Low, medium, high will be there, right? That only knobs are there in that also. If you want low, medium, high, usually we keep it in the medium or sometimes high, and we make sure it vibrates for 15 minutes. Is this point clear? First
Yes,
part,
ma'am.
make sure the sieve plates are arranged in the descending order. Then weigh 50 grams of the dry sand by using a digital balance and put it in the top sieve plate. Okay. Then make sure it is secured firmly so that there is no, while vibrating, those plates don't rip off and fall. Then you're going to make sure you're going to switch on the motor. Make sure the system is running on a medium to high conditions for 15 minutes. Is it clear? Clear?
Yes, ma'am.
Then the sand particles, once after the 15 minutes, the motor will be switched off. The sieves are then vibrated for 15 minutes, then the motor is switched off. Then the sand particles retained in each of the sieves are collected separately. Now we're going to remove one by one sieve plate and collect all the sands in a piece of paper. Name them, which is the sieve plate. Name the sieve plate and what. Put all the sand particles collected in that particular sieve onto the paper. Then you weigh it using a digital balance and note it down in your table. Okay. After that, you're going to corresponding weight of the stand with the individual sieve will be entered in the tabular column. Okay. So after that, the the percentage of weight will be is calculated. The percentage, you know how to calculate, right? The percentage, the weight on this, the total weight into 100 will be the percentage of the sand retained. I think you should know how to calculate the percentage of sand retained. How to calculate a percentage? You know what's the formula? Suppose on the first plate, the weight, the amount of sand collected is 5 grams. Then what is the percentage on the first sieve plate?
5 grams by the total weight into 100.
Total weight is how much? How much grams of sand you weighed and you put it into the
50,
vibrator? Huh?
50 grams.
50. Okay. 5 by 50 into 100. So what will be the percentage? Boys, how much will be the percentage?
10%.
10%. Okay. So it's basically 10%. Then after this, the percentage is calculated. Then you will be given a multiplier. This multiplier is basically fixed for the experiments. For this process, this multiplier is fixed, right? Multiplier is basically something like with the probability. Like in the probability, if you're doing a decision analysis or something, you will say that 50% it might be wrong, 50% it might be correct, or 60% it might be correct, or 60% 40% it might be wrong. Let you have some probability of the sand settling, right? So based on that, a multiplier over the process, over this process is being done repetitively, right? So based on that, we have some multiplier values here, right? Which we will be giving in the externals. You need to remember those values and put it according to each sieve plate. What will be the multiplier? That is the probability of sand has the probability of the sand that gets settled down in each particular plate, right? Then after that, what you're going to do is the quantity is multiplied by a multiplier for each sieve. Then the results are entered in the column of grain fineness number and is found by using the formula G. Then you have to find out the product. Product is nothing but R into S. You're going to multiply R into S and you will write down the value here, right? So then you're going to calculate what is the grain fineness formula. Grain fineness formula is nothing but this summation of y divided by summation of r. That is, we term this as y, we term this as x. So that will be y by x. Any doubts, boys?
Oh, ma'am.
No. So one last time, I'm just quickly going to go through the procedure. So the procedure will be, first make sure your sieve plates are arranged in the right order, that is in the descending order, and make sure they are clamped firmly. Then you're going to weigh 50 grams of dry sand and put it in the first plate of your sieve. Then the sieve plates, the sieve machine, the complete set is going to be vibrated for 15 minutes. Then the motor is going to be switched off. Then during this process, the sand particles will settle down in each appropriate plates depending upon their granular size. And what we're going to do is we're going to remove each plate and weigh what proportion of sand is settled down at each of these plates, right? After it has been settled down in each of these plates, we are going to take them and weigh it in a digital balance, right? And note down those weights here. Sieve plate numbers will be written here. Each particular sieve plate number plates weight of the sand will be noted down here. Then what we are going to do is the corresponding weight of the sand in individual sieve is entered in the tabular column. Then we are going to calculate the percentage of weight retained in each of the sieve. Then the multiplier will be given. The multiplier will have to be introduced here, will be written here. Then you're going to calculate the product. Product is nothing but you need to multiply percentage of sand retained into the multiplier. These values will be entered here. The purpose of this experiment is to find out what is the grain fineness number. So the grain fineness number will be summation of product by summation of percentage, which we call it as y by x. Any doubts in the experiment?
No, ma'am.
No. Okay. Now I want to show you a video.
Excuse me, ma'am.
Yes, Ashit? Yes, Ashit. Who's it? Anybody's having a doubt? Ashit?
What is multiplier in the table, ma'am?
That's what I told you, right? There is a probability because these experiments are conducted periodically over several years. Now, there is a probability of what is the ratio of sand going to settle down at each particular sieve, right? So, that decision or that analysis where we are adding a component to the percentage is the proportion of sand that has likely to be settled down each of the sieve plates is called a multiplier, right? Those values will be entered there.
Okay.
Okay.
Yes.
Is everybody clear? Can I move ahead?
Yes, ma'am.
Shall I play it? Boys, is this screen visible to you?
Yes, ma'am.
See, these are the sieve plates which is shown here. Can you see this? These are the sieve plates. Now, can you note down these values? 600, 425, 300, 212, 150, 106. These are the sieve plates which are arranged in a descending order. What is this? What is
Digital
this? Distal balance. First, how much gram we have to weigh and put it in the sieve balance, in the sieve vibrator?
50.
50. So we are measuring about 50 grams of the sand and we're going to plate. We have put it on the first portion of the sieve, close the sieve, and you have to clamp your vibrating machine sieve system. This complete sieve equipment has to be clamped firmly, right? And then we are switching on the motor and switching on the speed. After 15 minutes, it's been switched off. See here, I have noted down all the sieve plates here. I have about 11 plates, including the pan. I have 11 plates. Okay. So I have noted down all the sieve numbers: 1100, 650, sorry, 850, 600, 425, 300, 212, 150, 106, 75, 53, and pan. These are the sieve plates ranges which are written here. Then I have the initial multiplier factors which you need to remember and which is given for you all. For of 1700 your multiplier will be 5. For 850 your multiplier will be 10. For 600 it will be 20. For 425 it is 30. For 300 it is 40. For 212 it is 50. For 150 it is 60. For 106 it is 100. For 75 it is 140, and for 53 it is 200, and for the pan it is 300. I want you to take down these values first. Draw a table, take down these values. That experiment you should have before, you can write the title as grain fineness. What was the experiment name? Grain fineness test. What is the aim of the experiment?
Ma'am, what exactly is sieve number? Is it the diameter of the grains?
The sieve, that mesh kind of thing will be placed on the plate, right?
Yes, ma'am.
That the smallest amount of sand that it can accumulate there.
Yeah, like the diameter of the grains.
Yeah, it is all in microns.
Okay.
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 So what will be the aim of the experiment? The experiment name is grain fineness test. So what is the, are you please noting down this in a sheet of paper, because by the end of the class you need to plot these values, draw the graph and put it in your Google Classroom. Take a sheet of paper, write down experiment will be grain fineness test. Are you writing down, boys?
Yes, ma'am.
What will be the aim of the experiment? Can you all tell me? What is the aim?
Grain fineness test.
To determine average grain fineness number of the molding sand. That will be the aim. To determine average grain fineness number of the molding sand. Finished, boys?
And what is the 11th one?
11th value. I will tell you. First, you take down one by one. Have you noted down the experiment name? Have you written the aim?
Yes, ma'am.
What is the apparatus used? Next is boys, can you see? I've switched off the other file. Can you see this?
Yes, ma'am.
I want you to write down this. Apparatus will be digital balance, sieve shake equipment with a set of 10 sieves, stopwatch. What was given the apparatus? Note it down. Next, the material required is silica sand. Next, the material required is silica sand. Shall we go back to the video? No, you need to even get your have you noted down the materials required? After that, I want you to take down this tabular column. Grain fineness number for the tabular column. You have 11 pans. So serial number will be up to 11. Please note down this.
Ma'am, the screen isn't seen, ma'am.
I have not shared it. Once again. Is it been shared? Was it been shared?
Yes, ma'am.
Yes,
Okay.
ma'am.
So you will first take this table 1 grain fineness number. You have 11 pans. You have actually 10 sieves plus the pan. That means you have 11 sieves. So 11 serial number you will have to enter it. Then leave 11 sieve number spaces here and note down the rest of the things. Have you noted down? Was done. Have you copied it? Is the tablet completed?
Yes, ma'am.
Then I want you to plot the graph of percentage of sand retained on y-axis versus sieve number on x-axis. That means the sand retained value, percentage of sand retained should come on y-axis. Sieve number should come on x-axis. Don't change the this y-axis and x-axis. Is it clear? Whatever percentage of sand is there, that should come in y-axis. Sieve number should come in x-axis.
Can you show those values, ma'am?
I will give you. First, you see the video. First, you take down. Have you taken down? If you plot the graph of the first one, that's more than enough for me. Okay? Have you done this? Have you taken down the graph?
Yes, ma'am.
Percentage of sand retained on y-axis. Now, I'm moving on to the video. Is this video being shared with you? Can you see this YouTube video?
Yes, ma'am.
Okay, I'm playing it again from first. These are the values of the sieve which is shown here. Can you see on this plates? It is there. This is the digital balance. 50 grams of sand should be weighed. Then putting it in the sieve shaker, closing the lid, forming it tightly. Okay. Then you start the system. Boys, in the meantime, can you take down these values while the machine is being vibrating? Are you taking down, boys?
Ma'am, can you tell the sieve numbers, ma'am?
I'll tell. First sieve number is 1700. If you have done, say yes, ma'am. Second one, 850.
Yes, ma'am.
Third one, 600.
Yes, ma'am.
Fourth one, 425.
Yes,
Fifth
ma'am.
one, 300. Sixth one, 212. Seventh one, 150. Eighth one, 106. Ninth one, 75. 10th one, 53. 11th one is the pad. Boys, now I'm giving you the multiplier values. Shall I tell? Shall I give you the multiplier values?
Yes, ma'am.
First multiplier value is 5, 10, 20, 30, then 40. Then for the sieve plate 212, multiplier is 50. For 150 it is 60. Then for 106 it is 100. For 75 it is 140. For 53 it is 200. And for the pan the multiplier is 300. I'm repeating it again. You can cross check. The multipliers are, which goes in the order 5, 10, 20, 30, 40, 50, 60, then 100, then 140, then 200, then 300. Am I clear, boys?
Yes, ma'am.
Okay. Now we'll continue to see the video. Then the motor is switched off. Now we are unclamping the system. Now what you will do is, as you gradually remove one by one sieve plate, don't do this mistake if you're doing in the exam. Don't remove all the sand, put it in a piece of paper and then try to weigh. Usually you do tend to do mistakes. That means the papers, the pan size and the weights can get exchanged. So remove one by one and weigh it and immediately enter the value. Okay, like we have done here. So first sieve has been removed, that is 1700. It has been weighed and we're noting down the weight. 10 la?
0.10.
I'll show you the values at the end, okay? For the second sieve plate. If it is not coming, you need to press the tar button so that the value or the weighing balance initially measures the zero value there.
Would be 5.69.
The video is over, right?
Yes, ma'am.
So just a second. Now I want you to note down these values. Is it clear for you all?
Ma'am, can you share your screen, ma'am?
Oh, I'm sorry, I'm not shared the screen, sir. Just a second. Can you see it, boys? This value is 5.65. Copy it, boys. Is every copied? Okay, now I want you to do the calculation part. Percentage of sand retained and the product. Well, you can answer your attendance. K. Shashank,
Yes, ma'am.
Banu Pratap, Banu Pratap. You're all B1 batch, right? Banu Pratap, Bhavna. Students answer your
Present, ma'am.
attendance. Ayush Chandra,
Present, ma'am.
Ayush Dorje, Chetan Kumar,
Yes, ma'am.
Darshan, Darshan, Banu Shankar, Banu Shankar,
Present, ma'am.
Brijesh,
Yes, ma'am.
Kritik N, Kritik N, Harsha Ayappa, Harsha Ayappa,
Present, ma'am. Yes, ma'am.
Chiran, Chiran, Ashchit Kumar,
Present, ma'am.
Chinmay Shetty,
Yes, ma'am.
Yatindra,
Yes, ma'am.
Lalit,
Present, ma'am.
Karthik,
Yes, ma'am.
Abhishek,
Yes, ma'am.
Akash DK, Akash DK, Harshit Kumar, Harshit Kumar.
Earlier you said Harshit or Ashit, ma'am.
I said Ashit, 004.
Yeah, Ashit is me, ma'am.
Harshit have given you.
Harshit, I don't know, ma'am.
Harshit. Okay. Harshit is absent, is it? Harshit? 016. Adarsh Gautam. Boys, today in the classroom, I have given you the sieve calculations. I want you to do it and post it to get your marks for today only. Is it clear? I don't know if I posted in your class or have I posted in your class?
Ma'am?
Once again.
Ma'am, US and 21 has bad internet connection, ma'am. That's why he couldn't answer the attendance.
Who's you? What's his name? USN 21.
Kritik, ma'am.
What were you doing, man?
Ma'am, he's like he told me to tell you, ma'am, his internet is not working properly.
Okay. Boys, in your Google Classroom, I have posted your assignment. Make sure you complete it, okay?
Yes, ma'am.
And the graph is between what and what?
Yeah, graph also. Along with the graph, you need to post it.
No, what graph? Between percentage and weight.
I told you, right? The graph should be percentage of sand retained on y-axis versus the seam number on the x-axis.
Yeah, I was just confirm.
Okay. Now, what is it? Can you tell me the values? What values you got? Shall I call out and ask one by one? Now, for sieve plate 1700, what was the percentage? How much will be the percentage? Boys,
0.0, 0.2.
0. 0.2 or 0.2?
0.2, ma'am.
0.2. For the second one,
3.48.
3.48.
how much? 3.48. Okay. Similarly, for 3.29,
6.58.
6.58. Similarly, for 5.65,
11.3.
11.3. Similarly, for 8.12,
16.24.
superb, 16.24. Similarly, for 13.79,
27.58.
27. Next for 11.88.
23.76.
23.76. Then for 3.01.
6.02.
6.02. Then for 0.52.
1.04.
1.04. Put 0.02.
1.04.
0.04. Are you all getting the same values, boys? Boys, are you getting the same values? Only one is answering yes, ma'am. Now, can you multiply R into S and give me those values as well? Now I'm going to call out names. They have to give me. Akash G, what is the answer you got for the first one, for the first C plate? Akash G K. I'm noting down these names who are not responding in my class. Chinmay Shetty. Chinmay Shetty. Finish the calculation. Lalit.
Yes, ma'am.
Done. You multiplied R into S.
Yes, ma'am.
Can you give me the values, please?
Yes,
For
ma'am.
1700, how much you got? For C plate?
1, ma'am.
1. Then for the second one?
34.8.
34.8. For the third one?
131.6.
131.6. For the fourth one?
339, ma'am.
339. Super. For fifth one?
649.6.
649.6. For the sixth one?
1379.
1379. Super. For the seventh one?
1425.6.
Okay. For the eighth one?
602, ma'am.
602. For the ninth one?
145.6.
145.6. For the tenth one?
8.
8. For the pan?
0, ma'am.
0. Okay. Now what will be your grain fineness number? Did you do the summation of the complete of R and the percentage? That is y by x.
Ma'am, y by x value is 49.
Y by x value is 49. Very correct. Okay. Now what I'll tell you is you can plot the graph and you can post it in the Google Classroom. Okay.
Yes, ma'am.
Okay. If you have, do you have any other doubts in today's class?
No, ma'am.
No. Okay. If you have written everything, right? You have written the aim, apparatus used, material used, then the tabular column, then the value, what is the grain fineness number, the graph. This complete aspect should go into your Google Classroom. I've created an assignment, post it there. Is it clear?
Yes, ma'am.
The title of the experiment is sieve analysis I've given. Okay?
Can you repeat the title?
Sieve analysis. Sieve analysis.
Yes, thank you.
Okay. You post your graph in the Google Classroom. If you have no doubts, then we'll wind up. Boys, these marks will be considered for your marks for the lab. So make sure you all submit it. Is it clear? Okay.
Yes,
then.
ma'am.
Thank you.
Thank you.